Hi, how you doing? My name is Jose Manuel Garcia Bustos. I'm in my second semester of Mechatronic Engineer, and in this video I will explain about the resolution of the problem situation by the Dr. Jorge Lozano Aponte in the unit Formation of Chemical Experimentation and Statistical Thinking. Well, without anything else to say, we start with the video.
First of all, we must start with the context of the problem situation, in which we talk about how oil, the main element for making gasoline, has become increasingly expensive and scarce, and above all, a major environment pollutant. So the objective of the practice is to investigate where there are energy sources that can occupy a car that are just as functional and durable as a conventional gasoline car. The most effective method currently used are electric cars, which are vehicles powered by a battery capable of storing and generating the amount of voltage sufficient to move it. But what is a battery? The battery is an electrochemical cell, which is a device capable of converting chemical energy into electrical energy through the redox method, where the electrons generated by direction flow from cathode to anode, generating useful electric current. For the creation of our electrolytic cell that was able to move a mini electric car, we used copper as the cathode, where the reduction takes place, while magnesium was used to produce the oxidation. Since we have our cathode and anode, we need a salt solution capable of carrying out the reaction without the need for a salt bridge, so the simple salt for the reaction was copper sulfate. Since we have identified the elements with which we'll create our cell, let's see the complete operation of how it works. It all starts with our anode, which is the magnesium. In the reaction, the magnesium will lose electrons and will generate magnesium ions that will be responsible for being transferred to the copper on the salt solution. Then we have the cathode, which is the copper that will gain electrons by converting the copper ions from the aqueous solution to solid metallic copper. For this reason, it's necessary that the solution contains metal ions from the cathode, so the cathode can gain those ions. Since we explained the operation of the cell, we need to know the standard potential of the cell to know if our cell covers the necessary voltage to make the current move forward. So with a basic formula of cathode minus anode, we can check the theoretical potential in turn to know if our cell is galvanic, that generates energy, or electrolytic, that needs energy to activate. So the potential of copper is 0.34 volts, while the potential of magnesium is minus 2.37 volts. So doing a basic subtraction gives us 2.71 volts. That's not enough to fit the car, so we use two cells connected in series to double the voltage. So the final theoretical voltage is 5.42 volts, equating to a 5 volts battery. In practice, we obtain a voltage of 3.72, but this voltage could have been influenced by the time it took to take the measurements, so the cell lost power. We can conclude that it's a fact that we can use electrochemical cells as a source for vehicles, as they generate less pollution and use energy more efficiently, but they have obvious disadvantages, such as their high production cost and that we don't have an efficient way of handling and disposal the batteries that have their cycle complete and need to be discarded. So that's all of the video. I hope you like it, and thank you very much for watching it.